F1 and F2. This chart is in the back of your book. Or I'm sorry. Chart is in the back of your formula sheet. Know which is which. Know what happens in parallel and what happens in parallel and what happens in series. In series, the only at resonance, the only opposition felt in the circuit is what? The resistor. So total impedance, is it at its max or at its minimum? It's at its minimum. So total current is at its max. Okay. Impedance here equals resistance, and total current is max. Okay. At low frequencies, DC, all the voltage is felt at the capacitor, and all the voltage is felt at the inductor in at F2 or high frequencies. Okay, I'm not going to go over this one again. We already talked about 1 over 2 pi the square root of LC. That's the frequency of resonance. Calculating Q is the ratio of inductive power to true power, or X of L over R in series, right? Okay, and Q determines how selective the bandwidth is. Okay, how narrow or how wide, how many hertz are in the bandwidth. All right. So this is all at frequency of resonance. All the voltage drop is at the resistor. Voltage, total voltage across the inductor and capacitor at resonance is what? The total voltage drop across the inductor and the capacitor at resonance is 0. Yes. Is 0. Yep. Okay. So at F1 in series, the circuit is acting what? Capacitive. So the angle is going to be, for Z total, negative 45. And the net X sub C is going to be equal to this is 45, this is R, this is X sub C, and R equals 30. This is 45 and this is 90. 30. So this is 30. At negative 9. So these two things at F1, or at F1, X sub C is going to equal R, right? And this length is how much bigger? Square root of 2 times bigger. Okay. And define your bandwidth, frequency of resonance divided by Q, right? Or F2 minus F1. Current and voltage is 0.07 of its max current voltage. Okay, when I take 0.707 squared, I get like 0.4999 or half, right? All right. So F1, F2, I have half power at both. Okay, bandwidth, or figuring out F1 and F2, if you have the bandwidth, if you have frequency of resonance, you can divide bandwidth by 2 and add half of it to either side of the bandwidth to get, or either side of the frequency of resonance to get the bandwidth. Okay, so for F1, circuit is acting capacitively, so R equals X sub C, and the angle is going to be negative 45. At F2, it's acting inductively, it's going to be a positive 45. So if total impedance at F1 and F2 is the square root of 2 times bigger than R, how much smaller is current going to be at F1 and F2? Square root of 2 times smaller than what it was at residence. Yes? Okay. All right, the voltage drop across any specified circuit component that have power points. Well, if you have the current at F1 and at F2, which is 0.707 times the current, or divided by 1.414, which is the square root of 2, it's going to get you the same thing. All right, any questions on series resonance? No questions?